Hi class, today we're going to talk about the indefinite integrals and the net change theorem. So before, in 5.3, we talk about the definite integral and we learn FTC1 and FTC2. So today, we're going to talk about the indefinite so you don't have the restriction in the interval. So as you can see right here, the integral, we don't have the interval from A to B like we had in 5.3. So you need to understand the difference between definite and indefinite. Definite integral is basically a number. So we can evaluate, we get a number, a constant. Indefinite integral is a function or a family of function. This table right here is very important, as you know. Hopefully by now you can memorize some of the properties in this table, like the constant, and addition is quite easy. Power, you definitely need to know the power, and ln x. And if you can memorize some of the trig functions, that would be very helpful. And I remind you from time to time, arctangent is definitely one function you should memorize, because when you look at something like this, you know it's going to be arctangent. Okay, so we adopt a convention that when a formula for a general indefinite integral is given, is valid only on an interval. So if I want to integrate this indefinite integral right here, make sure you have to add the constant c here. Okay, so let's do a problem. So the first problem, as you can see, we have the power and the trig function. So I can definitely take out the constant. (10x to the 4th minus 2 secant square dx. Let's just break the integral and take the constant outside. So I have x to the 4th dx minus 2 integral secant square of x dx. Now we can integrate. So for this one, I have x to the 5th power divided by 5 minus, hopefully you recognize that secant square. So if you take the derivative of tangent, you're going to get secant square. So the antiderivative, we get 2 tangent of x plus c. And then you just simplify it. 2x to the 5th power minus 2 tangent x plus c. Okay, moving on to example 2. So as you can see for example 2 here, so we want to evaluate cosine theta over sine square. So hopefully you can recognize that we have to simplify before we try to integrate. So I can definitely break the denominator. So instead of writing cosine of theta over sine square, I'm going to write cosine of theta sine theta 1 over sine theta d theta. Okay. And then you can see that 1 over sine theta is cosecant. And then cosine over sine is cotangent. And if you take the antiderivative of that one, we will get negative cosecant theta plus c. Right? So make sure you simplify the problem before you proceed. This one right here, hopefully you recognize that we did this problem before using the Riemann sum, but now it's going to be so much easier. And this time we have the definite integral, so you can evaluate the point. So for this problem, I have 0 to 3 x cubed minus 6x dx. This is power rule, so we can easily do it. X to the 4th over 4, because we have the power is 3, 3 plus 1 is 4, and then make sure you divide by that same number. Minus 6x to the first power, so you add 1, so that's square, divide by 2. So I'm going to simplify that first. So we have x to the 4th over 4 minus 3x squared. Don't forget that if you still iffy about taking antiderivative, you can always check your answer by taking the derivative. All right, so we're gonna evaluate. So what I have is 1/4, and we have 3 to the 4th power minus 3 times 3 squared minus, and then you have the 0. So I'm just going to write it down for this problem, but eventually you know that we don't have to worry about the 0. All right, so we get 81 over 4 minus 27. So we ended up with negative 6.75. Okay, so that's how we evaluate. You see this problem right here, the first two terms, quite easy, right? The next one, you have 3 over x squared plus 1. Now, if you just have 3 over x squared, you can definitely move the denominator to the top and change to the negative power. But there's something wrong here because we can't really change it with x squared plus 1. So hopefully you still remember x squared plus 1 over x squared plus 1 is going to give you arctangent. Okay, so keep that in mind. All right, so let's do it. 0 to 2, and then we have 2x cubed minus 6x plus 3 over x squared plus 1 dx. I'm going to break it and evaluate. Oh, I'm sorry, integrate. So we have 2 x to the 4th over 4 minus 6x squared over 2. And that one's gonna give you arctangent. And then we want to evaluate from 0 to 2. Let's simplify it. So what I have right here is x squared over, x to the 4th over 2 minus 3x squared plus 3 arctangent, 0 to 2. Okay, now all we have to do is plug it in. So what I have is 2 to the 4th over 2 minus 3 2 squared minus 3 arctangent of 2. Okay, and then for 0, we're going to get 0. So let me just put 0 there. So to simplify it, I ended up with negative 4 plus 3 arctangent of 2. Of course, you can use the calculator to figure out that number, but I'm just going to leave it for now. This is the exact values. All right, moving on to the next example. As you can see right here, the next example, we definitely, in 4.9, I give you something similar. So before you do anything, make sure you simplify it, right? So we definitely need to simplify the function. So if I simplify the function, 2t squared divided by t squared, that's just 2, right? And then we have t squared divided by t squared, so we ended up with t square root of t, so I'm just going to change it to 1/2, minus 1 over t squared, so I'm just going to move it to the top and change it to a -2 right there, dt. All right, we are ready to take the antiderivative. So what I have is 2t plus t to the 3/2 over 3/2, I can simplify later, minus t to the -1 divided by -1. Okay, so let's simplify it. We have 2t plus 2/3, because you divide, so you multiply by the reciprocal, plus 1 over t. And then let's evaluate from 1 to 9. So what I have is 2 times 9 plus 2/3. Then we have 9 to the 3/2 plus 1 over 9. So that's the first part. And then you subtract by 2 times 1 here, plus 2/3 and 1. I try to write down everything. Okay, and then after that, you can use your calculator if you want. But what do we have here? 18 plus 18 plus 1/9 minus 2 minus 2/3 and minus 1. So we get 32 4/9. Okay, so for this problem, like I said, make sure you simplify the function before you integrate.